Hello everyone, I am Monika Bhushan and today we are starting lecture number 9 of partial differential equation. So in today's class we are going to cover the topic which is solution of partial differential equation involving derivative with respect to one independent variable only. Okay, so what does it mean? That means we are going to see the equations of PDE where we will be having only one independent variable. Okay, so that means if I'll talk about z, again the same concept, z is the function with respect to x and y both. But in today's equations we will be dealing with del by del x of z or del by del y of z. So in one equation you will find only del by del x of z, any form, okay? And in one equation you will find only del by del y of z. That means with respect to only one independent variable you will be having the differential equation. Either it will be your x in your complete equation or it will be your y in the complete equation. So once we will be seeing the question, it will be more understood, and then we will analyze the difference between last class solution and today's solution. Okay, so here are the questions. So the question is, solve the PDE involving derivative with respect to one independent variable only. So if you will focus on this question number A, so here the equation is what? This is solve del 2z by del y square equals z. That means what is your equation given to you? The equation is del 2z by del y square equals z. That means you don't see any del by del x of z. Okay, this is missing there. Though we know that z is the function of x and y both. Okay, and these conditions, if it is given to you, that means they just want to know that what will be the exact answer. So given that z is 0 and del by del y of z is sin x when y equals 0. We'll see the question number B. Here also it is given that solve del 2z by del y square equals z, given that some other conditions are there. Okay, so you might be having the question in your exam where it will be written as del 2z by del x square equals something. Okay, what is happening here? So here you will be seeing only with respect to x or only with respect to y, and not necessarily it will be your del 2z by del x square only. Okay, this could be your del z by del x and this fashion. Okay, and if you will focus on the difference between these type of equations and the equations which we have seen in lecture number 8. In lecture number 8, what was the topic? We had solved non-homogeneous PDE by direct integration method. Okay, so in direct integration method, the equation what was given to us was involving both derivatives. It was your del 2z by, instead of del y square or instead of del x square, maybe del x del y both are present in your equation. Okay, and so this is the difference that you will make out. And in this type of questions, if it is coming in your paper, suppose this question is coming in your paper, very first thing is this will come in your mind that which method I have to follow. Correct? No, if it is not written in exactly the same words, then you will find that this is, if it is written as del, that means this is 100% partial differential equation. Okay, so in partial differential equation you are just finding the derivative with respect to one variable only. Any order will be there, that is no problem. Fine, so we'll start the question. So this is the question what we had seen just now, and what we have to say here, that this given PDE, this is PDE because this is not written d2z by dy square, correct? No, it is written del 2z by del y square. So this is my partial differential equation. So this is my partial differential equation, but it has only one independent variable, and that is with respect to y. Okay, so that means I can assume that my this given equation is not PDE. I'll just say that I'm going to solve this equation just like how I used to solve the ODE. What was ODE? Ordinary differential equation. in my ordinary differential equation, whatever methods we had followed, we are going to follow just that method only. Okay, so in that case, if I just write down this equation, whatever they had given to us, so this equation is del 2z by del y square equals z. Even you can write here d2z by dy square also equals z. Okay, but we are going to write in this fashion only. Okay, so that means this is the equation only, and then we will be writing it in the simplified fashion, like how we used to solve the equation in our ordinary differential equation. So if you want to brush up, you can see the playlist ordinary differential equation. So what we had said there, that means we will be just rewriting it in the form of d operator. Remember that d operator was what? D was my, in that case it was d by dx or d by dy, whatever. Correct? No. So here we will be writing down that we are saying that d is nothing but del by del y. Okay. So if d is del by del y, so I can rewrite this equation as, so this will be my d2z minus z equals 0, or I can write it as d2 minus 1 z equals 0. Fine. So now how to solve this equation? Just you imagine that this is the ordinary differential equation, and this type of solution we had covered in lecture number 2 and lecture number 3. What is happening here? We are going to see the solution of above equation. So solution will be what? Solution of any ordinary differential equation is CF plus PI. Correct? No. But in this equation, we don't have to find PI. The reason? Because the right hand side is just 0. Right hand side has no any function. So this is the homogeneous equation. So I just have to find the CF of this above equation, and then I'll say that I got my answer. Okay. So what will be the CF of this given equation? Replace D with M. So that means I can write the above equation as m square minus 1 equals 0, and this is the auxiliary equation. The auxiliary equation does not contain the variable, that means z will not be there, and d will be replaced with m. So in that case you got that m square is 1, that means m is how much? M is plus minus 1. If m is plus minus 1, that means 2 roots you will be getting. Correct? No? Because 2 values you are getting. So finally we are going to write down the CF, and this is the formula which we are going to use in this solution, because the roots are distinct and real. Correct? No. So because both roots are real only and they are different, so we are going to use this formula. So since we have 2 roots only, so we are going to just add these 2 terms of this given formula which we had discussed already right now. That means this is my C1 e raised to m1. What is your m1? M1 is your m1 is 1, and your m2 is minus 1. You can write m1 is minus 1, m2 is 1, that is okay. So if I'll say m1 is 1, so e raised to y. Fine, because here my variable is y only. I'm not dealing with x. Correct? No. So the independent variable is y. So I'm writing down c1 e raised to y. Okay. And plus c2 e raised to minus 1. Here it is written. So minus y. Fine. So this is only the CF what I have got here. And this c1 and c2 are nothing but the arbitrary constant. Fine. So we got here that z equals c1 e raised to y plus c2 e raised to minus y. Fine. So we have also got the same thing. So this is only the equation. So this is only the solution of my ordinary differential equation. Correct? No, this is the solution of ordinary differential equation. But I have to find the solution of partial differential equation. Correct? No. So how to get the solution of partial differential equation? So only the difference which we are going to make out here is, now I am going to write in case of solution of partial differential equation, my equation will be rewritten as z equals the same thing. I am going to write z equals, instead of c1 and c2, okay, I am going to write down some arbitrary function. I'm going to write down any function name, fx, gx, any other name also. And the reason why I'm going to write solution of partial differential equation is fx e raised to y plus gx e raised to minus y. What is the reason? The reason we had discussed in lecture number 8, like last lecture only. In partial differential equation, we have said the reason that why we use arbitrary function, not arbitrary constant in partial differential equation. Correct? No? Yes, this is the solution of the of partial differential equation. Fine. But what they had given in the question, these conditions actually given to us just to find out the values of fx and gx. Okay. Given that z is 0 and del by del y of z is sin x when y is 0. Okay, so that means two things have been given to us. This is if y is 0, then z is 0, and the second thing is if y is 0, then del by del y of z is sin x. So these two things we will be writing down. Okay, so very first thing is, if I have got this solution of PDE, so first condition I can apply. Correct? No, that means when y is 0, z is 0. I can write here. So z is 0. I'm just putting the condition, first condition, z is 0 and this is my fx, y is 0. So e raised to 0 plus this is my gx, e raised to minus 0. That means 0 equals e raised to 0 or e raised to minus 0, both will be 1 only. Correct? No, anything which has power 0 is nothing but 1. So this is my fx and then this is nothing but gx. So I can write down that fx equals minus gx or gx equals minus fx. So one relation between fx and gx we have got, and one more relation if I'll get, then two unknowns and two equations if I'll get, that means we will be getting out the values of fx and gx. Correct? No. So second value will be what? So here it is written that del by del y of z is sin x when y is 0. That means I have to find out the derivative of z with respect to y, then only I will be able to apply this condition. Right? No. So here, because of that reason only, the next step is differentiating z partially with respect to y. So sometimes we get confused that why I have to find that partial differentiation here, because they have only given us the value of del by del y of z. So to utilize that, we are going to write down what is del by del y of z. Okay. Okay, fine. We are going to write here the equation again. Z is fx e raised to y plus gx e raised to minus y. And I'm going to find what is del by del y of z. So here also we are going to use the product rule, and here also we are going to use the product rule. So it will be how much? It will be your fx with respect to y. If I am finding out partial derivative, that means fx will be treated as constant. Correct? No. So fx I have just kept aside, and just I am finding out what is del by del y of e raised to y. Similarly, what is there? Plus I am writing down e raised to y into del by del y of constant will give me 0. Fine. Similarly, for the second term also, this is for my first term, right? For my second term, what I am writing down? So with respect to y, this gx is constant. So u into v, correct? No. So this is gx into del by del y of e raised to minus y plus this is e raised to minus y and then del by del y of gx. That means this is constant, so it will give me 0. So I am writing down here fx, and del by del y of e raised to y will be e raised to y only, correct? And this is 0 plus this is your gx is as it is. Del by del y of e raised to minus y will give you e raised to minus y, and again because of minus y it is nothing but minus 1, and then this is nothing but constant, so it is going to give me 0. So finally I got fx e raised to y minus, because of this minus, this is my gx and then e raised to minus y, and this is my left hand side is del by del y of z, and they had said that del by del y of z is sin x. So I am going to write here this is nothing but sin x. Okay, no. So this is sin x. That means I can utilize this relation. Fx is nothing but minus gx, right? So I'll write down here sin x is nothing but fx is minus gx, correct? So minus gx I'll take out common, right? So if I'll take out minus gx common, so it will give me how much? It will be nothing but e raised to y plus, because minus gx I have taken common, e raised to minus y. Okay, fine. So now what does it mean? Y is 0. That means I'll put y as 0. So it will be nothing but sin x equals fx, and y will be substituted with 0 minus gx and e raised to minus 0. So finally this is nothing but fx, and this is 1 only, correct? No, minus this is my gx, this is also 1. So this is my sin x. Okay, so we got another relation also. Fine. So I can write as sin x is equal to how much? Minus gx, if I write down as fx, so this will be nothing but fx plus fx, correct? Minus gx is my fx, so it will be nothing but fx plus fx, 2fx. So we got that fx is sin x by 2. Okay, sin x by 2, and hence gx will be how much? Gx will be minus fx, so this will be minus sin x by 2. So we got what is fx, what is gx. So the solution of PDE is written here. Z is fx e raised to y plus gx e raised to minus y. Or I can write down, instead of fx, I can write down sin x by 2. Instead of gx, I can write minus sin x by 2. Correct? No? So I'll write down here. Fine. So I'm going to write down the solution of PDE. Here is z is fx. It was what? Fx e raised to y plus gx e raised to minus y. That means I'm going to write sin x by 2 e raised to y plus gx is minus sin x, correct? No, minus sin x by 2 e raised to minus y. So this I'll write down here only, this is nothing but minus. Okay, and then here only I can leave as answer, and even I can simplify more. That means I can take sin x common, and then I'll write down here e raised to y minus e raised to minus y divided by 2. And why we are making in this form? Because this form actually gives us the idea of hyperbolic function. But this hyperbolic function is sine hyperbolic or cos hyperbolic. Okay, so this confusion always present. This is your sin x, and this is your, since minus is present in between e raised to y and e raised to minus y, so this is your sine hyperbolic. Okay, okay, so how to memorize it? If it is your e raised to y minus e raised to minus y by 2, it is your sine hyperbolic y. And if it will be your, suppose, e raised to y plus e raised to minus y by 2, it will be your cos hyperbolic y. So we know sinus, correct? No, sinus. So sine is for minus. So this is your minus. Okay. So if in between e raised to y, e raised to minus y, if it is minus, so this will be your sine hyperbolic. Okay. And if it is plus, it will be your cos hyperbolic. So we got the answer, correct? No. So this is the answer of PDE. Answer of PDE, which is involving the partial derivative with respect to one independent variable only. Okay. So second question, if we will start. So here it is written that this equation is given to us. So the equation again says it has the derivative with respect to only one independent variable, which is y. It could be x also. Okay. So now we are going to write as, since we are seeing only one independent variable, okay, so that means this partial differential equation, for now I can imagine that this is nothing but ordinary differential equation. Okay, so in that case I can write it as del 2 z by del y square equals z, the same equation I have just copied. Okay, because these things are nothing but just the conditions. Or I can write it as d2z minus z, I am taking z in left hand side, minus z equals 0, because del by del y I am treating as d, correct? No, so we are writing it in the form of differential operator. So I can write down d square minus 1 z equals 0. That means this is nothing but, that means we can now write down the auxiliary equation. Auxiliary equation is nothing but replace d with m and don't write the variable, and this is 0. Okay, and since this is the right hand side, the function is not present, this is my homogeneous equation. So I just have to find the CF of this said ordinary differential equation. We are not going to find the PI. Fine. So we are going to find that m is nothing but plus minus 1. That means the CF will be only, right, the CF will be only these two terms of this given series. So we got, this is the equation. Fine. No, either you write this minus y first or plus y first. This is no, so there is no problem in that. But this is the answer of, this is the solution or answer of ordinary differential equation. Since this is, we had treated this as ordinary differential equation, so we added the arbitrary constant, correct? No, but if we are going to treat it as solution of partial differential equation, so we have to replace this arbitrary constant with arbitrary function. This is the difference between ordinary differential equation solution and partial differential equation solution. So we have written down fx and gx here also. Fine. And then here only we can use, so this is actually your solution, right? But to get the answer of fx and gx, the same thing we are doing here also. We are writing down that what is the condition given to us. Here it is written that z is e raised to x and del by del y of z is e raised to minus x when y is 0. That means if y is 0, z is given, y is 0, and then del by del y of z is given. Since del by del y of z is given, so we will be actually further, we will be finding out partial derivative with respect to y also. Okay, and here we can substitute the value of z with e raised to x. Okay, fine. So here they have written down that we are going to differentiate it partially with respect to y, and then we got here. Fine. And then finally we are going to substitute the value z as e raised to x, and then del by del y of z as e raised to minus x. Okay. So two equations we have got, then we can, and we have two unknowns fx and gx. So we can find fx and gx here also, right? What I can do here, these two equations if I will add, so it will be how much? It will be your e raised to x plus e raised to minus x will give you how much if I'm adding these two. So fx and gx, fx and minus fx will get cancelled. It will be your 2 into gx. Fine. That means you got what is gx. Gx is nothing but e raised to x plus e raised to minus x divided by 2. It gives you what? This is nothing but hyperbolic function, but whether this is your sine hyperbolic or cos hyperbolic, so sinus, okay, no. So if minus is there, then only it will be sine. So this is nothing but cos hyperbolic x, and then fine. So this is your cos hyperbolic x. And what will be your fx, right? What will be your fx? So to get fx, you can subtract these two equations, okay, no. E raised to x minus e raised to minus x, because I am subtracting these two equations. So this will be your plus, right? No, fx minus of minus fx, that means it will be nothing but 2 into fx, and if I am subtracting, so gx and gx will get cancelled. So that means your fx is nothing but e raised to x minus e raised to minus x divided by 2. That means here you got your sine hyperbolic x. And then you got fx and gx. If you got fx and gx, that means you can write here the solution of PDE is what? Z is, this is whatever that sine or cos hyperbolic with respect to these two things. So, okay, so what we have written down here, okay, fx and gx we have got, fx and gx we have got here also, correct? No. So that means I can write here the same thing. So sine hyperbolic and then cos hyperbolic with your e raised to minus y and then e raised to y. In this fashion, we actually get the solution of those equations where you will find that del is present. Okay, no. So del by del y of something is present, any order, that is okay, or del by del x is only present. You are not finding del x and del y both in the given equation. So that means you can say that you are going to solve this type of equations using the method which we have just discussed now. Okay. So if you find this class useful, please like and subscribe my channel. Thank you.